Perfect. And we're
Done
ready when you
and
are.
done. Pardon me. I'm still recovering from a little bit of something. I don't know if it's a cold or just allergies that managed to end up in the wrong place, but I'll try and keep my voice well lubricated. So yeah, thank you everyone for joining this morning, this evening, this afternoon, wherever in the world you are. I have the distinguished honor of kicking off the Tungsten Fabric series of presentations for this DTNF. I figured I'd start out right back to basics about how we actually get the darn thing installed and do stuff with it. I'll give a brief kind of tour of Tungsten Fabric's architecture, just in case anyone has ever wondered. And then, of course, walk through kind of an example install manifest and talk about where we can get some of the most important parts of the documentation. I am not fully hiding in my garage this morning. I've managed to find a quiet place in my house that still has a chair, but I don't have the benefit of my usual plethora of screens. So if anyone wants to drop questions or comments in chat, I'll try to refer to it frequently, but I won't have my usual sidecar window. Casey, if I could ask if there's anything particularly earth-shattering or salacious, just call out.
Sure thing.
Cool. All right. Yeah, even keeping the chat open is going to be hard, but we'll figure it out. All right. So getting started with Tungsten Fabric. I already ran through the agenda. We have in the Tungsten Fabric community an incredible overlay SDN solution that is focused largely on OpenStack and Kubernetes networking. We offered a novel approach to OpenStack networking and a couple concepts of Tungsten Fabric have now, especially overlay SDN, have found their way into becoming like the de facto mode of operation for CNIs in Kubernetes, kind of validating the way that we do things in TF and providing ways that TF can do cool things in Kubernetes as well as in OpenStack. Over the past couple of years, we've been working to make TF more consumable. So we've improved our architecture through better packaging and better installation. Some of the technologies that I'm going to talk about today, like ansible-deployer, are the direct results of trying to make Tungsten Fabric more accessible to folks who could benefit from it. All of this is to say that our goal, as you're reading right now, is to build something that can be ubiquitously deployed easily to deliver scalable and secure clouds. And the cool thing about TF is none of this is a theory. We have shipping software that powers production infrastructure all over the world. So Tungsten Fabric is delivering on its mission. If you're curious about the Tungsten Fabric community or the folks who pull all this together, we are really a community of users. We have a lot of folks out there who are consuming Tungsten Fabric and doing awesome stuff with it. We also have a set of folks who contribute code. So thank you all to the members of the community, especially our contributors. Our community is now largely online, focusing around our mailing list and Slack. The in-person, virtually in-person meeting that we host weekly is our TSC. That's at 10 p.m. Pacific that we host on Zoom. So if you are curious about TF, obviously you can come and hang out with us. That'd be super cool, but you don't need to. You can check us out on Slack, on GitHub, on YouTube. And I'll be going through some of the highlights of the documentation, kind of the things that will make it easiest for you to get started with TF. There is one call out. Actually, I should have added this to my slides before the presentation. So big apologies to the CloudStack community. CloudStack has just announced an integration with Tungsten Fabric, adopting Tungsten Fabric as one of their modular networking solutions. So we'll actually be hearing from a member of the CloudStack community later today. But they have done a lot of cool work already with their initial integration and have published some blogs, YouTube videos, and documentation. So you can definitely check out Tungsten Fabric in someone else's community as well over in CloudStack land. So we are an SDN solution in 2023, which means we are kind of a buzzword bereft of market mass. Software-defined networking burst onto the scene with incredible promises to do literally everything, revolutionized every aspect of networking, and largely didn't deliver on those promises, except for a couple of really important places. While OpenFlow was off making a whole bunch of noise and generating a bunch of buzz and excitement in underlay and in switch fabric topologies, overlay SDN was quietly solving some pretty huge problems. You saw overlay SDN as ultimately the architecture adopted in a lot of production SDN solutions for the likes of OpenStack, VMware, and then later on Kubernetes. The notion of hiding the virtual topology of a cloud, or cloud tenants, I should say, is incredibly useful. It lets us have complex and robust network segment topologies inside of servers, abstract all of that away from the physical infrastructure, and then kind of selectively break out connectivity where we need it. So it gives us a lot of, or pardon me, I should say, it allows us to hand over a ton of control to the tenants of a Tungsten Fabric platform. They can create their own networks, plug VMs into it, create load balancers, modify security policies, and all without any engagement from an infrastructure owner or operator. Connectivity is, of course, a lot of what we do. Security policy, so like the two polar aspects of network forwarding, both forwarding traffic as well as selectively dropping it when you're told to, are vital parts of Tungsten Fabric. So within Tungsten Fabric, we can deliver full layer 2 and layer 3 stretch inside of OpenStack. We implement security groups in a stateful fashion, providing distributed security policy, and all at some pretty impressive scale. The kernel module throughput of Tungsten Fabric is multiples 10 gigs from a node with absolutely no tuning whatsoever. So we managed to pull all of these robust features off at a pretty hefty packet per second rate. Tungsten Fabric also benefits from a lot of partner integrations from the open source community, namely from the likes of Intel. We have an accelerated version of our data plane that leverages DPDK and pull mode forwarding to get blistering fast performance. And Intel recently contributed the implementation for offload and acceleration with their N3000 network interface. So this is all to say, I mean, not that this was meant to be a sales pitch for Tungsten Fabric, but there's a ton of cool stuff that we do in Tungsten Fabric. And that's really the benefit of such a mature and robust solution, is that we're not talking about promises, roadmap, and things we'd like to develop. These are things that Tungsten Fabric can do and is doing out there in industry and in production right now. I just want to drill home the point of overlay SDN, and then we'll skip right on into some of the walkthrough of the deployer and deployer artifacts. I've said overlay SDN a bunch of times, and overlay is kind of a jargony term from networking, so probably best to define it. Overlays are tunnel-based architectures that literally allow you to overlay one network topology atop another. Overlays are everywhere in networking. We build virtual circuits now for almost everything that we do, because in telecommunications, there isn't really the physical circuit path for anything anymore. You know, hitherto back in the sepia or maybe even black and white days of telecom, we would have a pinned up circuit if we needed to communicate between two places. But nowadays, instead, we get, you know, time sliced or some division switched. We're always logically multiplexing virtual connectivity on top of our physical medium. And so overlay SDN brings that concept into the data center. It allows us to build these kind of over-under views that I'm showing you right now. Wow, all of my greens and blues are yellow. That's really frustrating. Sometimes the copy paste of different icons messes with the colors, and I did not see this. So sorry about that. We can we'll go with the labeling and it can be a virtualized green and blue, yellow still, fully emulated. Right, our overlay SDN lets us build these logical topologies inside of compute infrastructure without having any sort of configuration in our physical infrastructure, which is what we refer to as the underlay. If you want to think of this like an OpenStack network, if you want to get really pragmatic, you can think of each virtual network here as a network inside of OpenStack, where we've created a network, for example, the green network, and we've added a whole bunch of VMs to it and plugged those VMs in. Tungsten Fabric will provide layer 2 and layer 3 reachability. I mean, it sounds super basic, but if we look at the underlay view of what's going on when VMG1 tries to communicate with VMG2, we see that those two virtual machines have actually been scheduled to hosts on different sides of this PowerPoint slide and the data center. Bridging the gap between the hosts on the slide and in data centers are those overlay tunnels. So when G1 wants to communicate with G2, the Tungsten Fabric vRouter running on the host will do a lookup, and it will see that the destination for G2 is this server on the right side of the slide. And the destination address will be that server's interface. So the vRouter will encapsulate the packet, it'll wrap it up in a tunnel header and destine it over to that rightmost server. All of the switches and routers in between those two servers, in this case, all of these three PowerPoint icons, just see the tunnel traffic. So they just see the outer header of that packet, the header that shows traffic going from the left side of the slide to the right side of the slide. That means that the underlay network, the data center, doesn't need to know anything about our green virtual network, doesn't need to know anything about G1 or G2. It just needs to know how to get packets between the servers and the data center. That separation of concerns means that the data center configuration, the physical devices, can be much, much, much simpler, and all of the complexity gets held inside of the servers. There's another important point here, just to underscore, is the scenario that I started out with is showing G1 and G2 communicating in the same subnet. So Tungsten Fabric and the vRouter data plane actually let you stretch L2 segments in some neat ways across your data center. I'll talk a tiny bit more about that later. Another cool trick that we do inside of Tungsten Fabric is distributed routing and forwarding. So it is obvious, I guess, in the first scenario that one vRouter would send traffic to another vRouter, but what if traffic is staying on the same node? So in this case, we have traffic from G3 in the green network going to B1 in the blue network. This is where another cool trick that Tungsten Fabric has up its sleeve comes into play. Because Tungsten Fabric can absolutely route between networks. We can create a network policy inside of Tungsten Fabric that permits traffic to go from green to blue. Those Tungsten Fabric network policies can actually inspect traffic types. So not L7 application layer traffic inspection, but 5-tuple stateful firewalling kind of header analysis. So this thing is essentially acting like a stateful firewall. And so you can create your rules that say, like, only in this example, HTTP traffic is allowed between these two networks. Some cool stuff is going on down in the underlay, though. If we look, like I said, those two VMs are on the same compute. Tungsten Fabric supports distributed routing, though, so there's no need to bounce these packets all over your data center or to find like a physical special routing or services node. Instead, every compute node in a Tungsten Fabric cluster can perform routing. And so the packet is routed directly from G3 to B1. And as you might imagine, the performance intra node is incredibly fast. So any time or performance we save from not having to encapsulate traffic is obviously super beneficial. The last trick that we have up our sleeve is traffic redirection, also known as PBR. Not that particular American beer, policy-based routing. This is an old trick in networking, which is to essentially override the decision of the routing table and redirect a packet to another destination, usually for the nefarious purpose of changing the payload of the packet or doing some form of inspection. I say nefarious in jest. This is super common practice in enterprise networks to introduce security through appliances and middle boxes, to introduce traffic inspection, or in telco networks, I'm sorry to say, it's a common pattern to introduce billing to a network complex. Whatever your reason for doing this, Tungsten Fabric has you covered. For a minor twist on the last scenario, when we're routing between B2 in the blue network and Y3 in the yellow network, sure, we create our network policy that permits that traffic. So Tungsten Fabric is going to allow it to be forwarded, but we can configure virtual machines or containers that we give special purpose to. We call these service instances. And when we designate a VM or container a service instance, it becomes a next hop for a service chain. A service chain are those policy-based routing rules. It basically says it's an action actually in your network policy. So when you allow that traffic between blue and yellow, you can optionally say, redirect that traffic through one or more service instances to do something to the traffic. My favorite demo for this, by the way, and I haven't done it in a while, so this is a good reminder, but if you're ever looking to showcase service chaining to your friends and wow your colleagues, you can route HTTP traffic through a simple Linux VM that uses image magic to flip images upside down. You can basically have an upside downer for your network. With the advent of HTTPS everywhere, you can't do this like just generally to people anymore, but in the contrived environment of a demo where you can manipulate and intercept traffic, it's still a cool trick. So yeah, whatever reason compels you, Tungsten Fabric can redirect traffic to these arbitrary service instances. Like I said, maybe bearing one of the most important details here, but these can be any VM or container running in Tungsten Fabric. It's essentially any combination of interfaces. So you have a ton of flexibility, even if you want to use my funky Linux image messer-upper as your instance, it will totally work in Tungsten Fabric. So like I said, I'm not talking theory. Everything that I talked about, you can do today and you've been able to do for years with Tungsten Fabric. There are people out there testing and deploying this stuff at scale. If you want to configure Tungsten Fabric, there's two popular ways to do it. There's our UI, which after all these years, I still really like. It's super responsive. It dispels a lot of the mystery as well behind SDN operations. So as a router person, the one thing that I always am hankering to do when things aren't working is look at a routing table. The Tungsten Fabric UI exposes all kinds of troubleshooting tools to let you see things like routing tables, interface metrics, stats, and flows to tell you what the heck is going on inside of those servers. You can also configure everything inside of TF through our REST API. The UI is actually a front end for the REST API. So, the UI, I guess, consumes a subset of all of the API endpoints, but you can do anything in TF through the REST API. There's Python binding as well, or Python bindings as well, and as bindings for other languages, depending on what you're writing your API client in. And these are all mature and robust interfaces. They're used by many organizations. Yeah, one of these days I'm going to have to do like a advanced level walkthrough of the TF UI because there's stuff I just am bursting to tell you all, but I'll have to save it for another day. The last thing that I want to talk about before we get into the installation artifacts and walkthrough is the architecture, because I've told you what TF is, what it does, how you can use and configure it, but I haven't told you kind of what we're going to install and where and why. There's two major kind of functional blocks of Tungsten Fabric. There's the controller complex that has the controller, the config nodes, the config databases, and optionally the analytics complex. And then there is kind of the compute complex where we've got the vRouter agent as well as the vRouter data plane. When we start going through our installation, we will pick servers in our infrastructure and give them these various kind of macro roles. And we can also, I'll show you as well how the microservices break out. One of the most important parts of Tungsten Fabric, and it often gets kind of buried in all of the noise and excitement talking about SDN and cool networks, but the most important point about Tungsten Fabric is actually up top. It's that orchestration nodes and the TF orchestration plugin calling the shots at the top. Because although Tungsten Fabric gives you a lot of power and flexibility to create arbitrary networks, Tungsten Fabric plugs into an orchestrator like OpenStack, Kubernetes, or now Apache Cloud. And it's through those orchestrator interfaces and interactions the networking gets configured. So you're never plugging in something arbitrarily into the Tungsten Fabric data plane. Instead, you're instantiating a VM or a container, and the orchestrator managing that VM and container plug the workload into Tungsten Fabric and its data plane. Some other important points of the architecture. First of all, there is obviously distributed control and forwarding plane. So we've got the controller complex and the vRouter forwarding complex that I mentioned. The vRouter is a kernel module typically, or DPDK application that gets installed on every compute node. And the controller is just a pile of containers that work together to deliver the distributed system that is Tungsten Fabric. All of these bits and pieces communicate to each other over XMPP, or I should say more specifically, the controller and vRouter can communicate with each other over XMPP. XMPP acts as an enriched kind of flow and routing protocol for us. So route updates as well as first flow lookups and instructions go over the XMPP channel and allow the controller to tell vRouter what to do with traffic or packets it's trying to forward. As I've been talking a fair amount about as well, Tungsten Fabric is tunnel-based. So you can see that lovely blue tube going between the two compute nodes, proving that the internet and all networks are indeed a series of tubes. This begs the incredibly important question, what happens when I need to leave the tube? If we are an overlay-based solution, then obviously we need to talk to networks, underlay networks at some point to get traffic into and out of all of the things we're running inside of our cloud. You have two options to do this. You can form a BGP peer with a router, switch, or firewall that supports the tunnel encapsulations that Tungsten Fabric does. The tunnel encapsulations, by the way, are MPLS over UDP, MPLS over GRE, and VXLAN. Those three encaps are incredibly common across multiple vendors, multiple types of networking equipment. You can find support in everything from like a micro tick all the way, obviously, up to a giant Juniper chassis router and a bunch of things in between. In order to get traffic out of your overlays, then what you do is you connect your SDN cluster, you connect Tungsten Fabric to a router that understands your overlays. And that router's job is to route between the non-overlay part of your data center and the overlay part of your data center. It's basically a big tunnel terminator and concentrator. For convenience, as well as for a bunch of other reasons, you can also turn off the overlay. I'm going to say this really slowly because this is the most important thing for everyone out there trying to build Tungsten Fabric labs or try Tungsten Fabric for the first time, and you don't want to set up a complicated tunnel router. You can turn off the overlay on a per virtual network basis. The feature you are looking for in the virtual network configuration is called IP fabric forwarding. That's right, you forward the virtual network to the IP fabric underneath the server. I get it, poorly named and tenuous, but like that's the logic why it's called the way that it's called. When that knob is enabled, traffic to and from that virtual network will no longer be overlay tunneled. You still need a BGP peer to your underlay because the underlay network still needs to know about the routes inside of Tungsten Fabric, but the route coming out of the servers now is going to be just a plain old vanilla IPv4 prefix. So no special tunnel configuration or tunnel capabilities are required. And I think that's it for this architecture. We talk XMPP to each other. We talk BGP to the outside world. The BGP address family is based upon the tunneling caps that we're using. So if we're using any of the MPLS encapsulations, it'll be the INET VPN address family. It'll be the EVPN address family in BGP if we're using VXLAN, and it'll be the INET IPv4 or v4 unicast address family if we're using that IP fabric forwarding knob that I hope you should all check out for your labs and stuff. It will make your life easier. Oh, I forgot that I included this slide. Super helpful. Okay, so inside the controller, I mentioned, trust me, folks, we're narrowing down to the meat and potatoes. I hope this has been a fun walking tour of Tungsten Fabric, but thanks for bearing with me. So let's talk about what we're going to be installing. And I said that the control plane complex was a pile of containers. Not wrong. Look, they're a pile, even if they're kind of beehive-ish. We have decomposed all of those piles of containers into functional blocks that make up the various microservice functions of Tungsten Fabric. That's right. I tried to seriously use the word macro together. It's 6:30 a.m. I request your indulgence. Our pile of containers, we divide them into functional blocks. Those functional blocks are things like config and control, analytics, and analytics DB. The functional blocks let you basically decompose your controller complex and scale the individual functions of Tungsten Fabric independently. So you could, for example, if your Tungsten Fabric deployment has, for example, a great deal of analytics queries, maybe you're doing per minute billing and you're retrieving the metrics from the analytics database constantly. Well, you can scale up your analytics database API server, you can scale up the backend, all without touching your config and control complex. Similarly, if you have a bunch of BGP sessions that you're running, you can spin up multiple config and control. Kind of scratching here, but hopefully you get the point. You can manage these things separately. You also control kind of what you deploy from ansible-deployer, which I'll show you in one brief minute. You control kind of the placement of the containers with these big macro blocks. Tungsten Fabric's control complex only requires a container runtime. You don't actually need to run the vRouter data plane on the controller. That started to change with things like Kubernetes. You're seeing more and more need to inject traffic into the overlay as well from the controller. So if you look at like how a Kube API server works in Kubernetes, the API server is reachable via the pod network, which is an overlay connected network, as well as via the underlay, like on the host address. So the data plane is getting deployed in more and more places, but strictly speaking, the controller can just live on whatever VM or bare metal server that you have laying around. And then the compute nodes themselves, they get a macro block of microservices called vRouter agent. So that includes the vRouter data plane, whether that be the kernel module or the DPDK application, and then as well, a container called vRouter agent that's responsible for the config and control of the node. I think that's it about the architecture, and that should be my last slide, I think. Oh, no, okay. Some details. So we're gonna cover the installation now, and I've got some helpful details about the installation. The kind of default, call it, installation of Tungsten Fabric is with Kolla OpenStack. I know the CloudStack community is working very hard to change that. Good luck to you, CloudStack community. We applaud your efforts. And we really do, because we always want more places and more ways to deploy Tungsten Fabric, because yeah, our default, our de facto right now is Kolla OpenStack. That means we're using a fork of Kolla Ansible-deployer to deploy Tungsten Fabric. This is an Ansible-driven approach, obviously. The installation is divided into 3 steps that don't neatly fit onto one line. So sorry about that. But the first step, you can see from the Ansible playbook callouts, the first step is always to configure instances. Then we install the orchestrator. So this could be install OpenStack or install Kubernetes. And then finally, the poorly named install Contrail playbook, which is what you use to, of course, get Tungsten Fabric. Those 3 steps are all that's required to get a working Kolla OpenStack and Tungsten Fabric environment, which is pretty slick, but there's a lot that goes on in all of those steps. So let's talk about them a little. The other thing I want everybody to screenshot, and I'll have this up again, I'm going to switch the screen share in a sec, but I'll switch it back and I'll make sure to flash this at least one more time. I want you to all pay attention to the location of the Kolla ansible-deployer container. That's right, even the deployer itself is containerized and hosted on Docker Hub, and that means that when you're installing Tungsten Fabric, you don't need to worry about things like dependencies. You don't need to set up your Python environment a particular way, or set up anything in the host. Instead, the TF Kolla ansible-deployer container can be used as a kind of one-stop shop to run the 3 steps you need to get Tungsten Fabric running in your environment. It's my favorite thing in the world. Honestly, the fact that I don't have to set up installer VMs or environments anymore is just great. So yeah, I hope it saves you all some time as well. So I'm going to stop the screen share. This will probably be a good time for me to check the chat, which is empty. And wow, we've got more people. So welcome all of the more people. Glad to see you hopping in while I was rambling away. Let me just make sure there's nothing embarrassing in my config before I share my window. Nope. Okay. I'll find new and usually verbal ways to make a fool of myself. Matt Vey asking the $1 million question, because it's only 3 steps, Matt Vey, but how much time is needed for those 3 steps? A fair amount. Deploying Kolla OpenStack isn't exactly quick. So we've got kind of the 3 steps: configure instances, install OpenStack, and install Contrail. Configure instances is normally pretty quick. That's like a 5-6 minute affair. Install OpenStack takes time because you're pulling down all of the Kolla OpenStack containers and then configuring them all. And then install Contrail, which actually installs Tungsten Fabric. That step takes about, I don't know, 10 minutes. It's much shorter than the OpenStack install. As a reminder, just because Ansible has kind of faded from the front of mind recently, and everyone's talking about new automation frameworks. Ansible's still out there, still supremely awesome. Just people don't get as excited about it anymore is all I'm saying. But I will remind you all that Ansible is idempotent. So the way that Kolla Ansible set up and the way that Ansible itself works is that if you have problems with any of these steps, especially the long ones like install OpenStack, you can run that step again and it should fail its way forward. You can always interrupt and restart the install. There's a couple exceptions to that. I can't think of specifics off the top of my head, but installs can get themselves into broken states. So just be wary if you run the install a bunch of times and then something seems weird in your environment. It's probably the fact that you ran the install multiple times. But yeah, by design, all this stuff is meant to be idempotent. So what are we looking at? We are looking at the instances.yaml configuration for Ansible deployer. In this YAML configuration, we outline all of the resources needed for our installation. Remember, Ansible is nominally SSH based, so we need to give Ansible some form of auth creds to log into the nodes that we're going to have it install on. There's a couple different providers for sorry, I just need to do not disturb my computer here. Or not. All right. Anyway, carrying swiftly onwards. So yeah, Ansible is going to try to connect to any of our install resources, usually using SSH. So we give it creds, either keys or passwords. Things like NTP and domain suffix are important because in that configure instances step, ansible-deployer is actually going to go in and do a whole bunch of host-based configuration on all of the server inventory that we specify here. So BMS also tells, I should say, Kolla ansible-deployer how to manage the infrastructure you're about to give it. So BMS is a bit of a misnomer. BMS is, well, bare metal server, and really what this is saying is ansible-deployer should SSH into everything you're about to give it in terms of inventory to perform the installation. There's a couple other providers, things like, I think there's an AWS one, there is a GCE one, there is a KVM provider, and all of those providers that actually have connections to a platform that has resources, you can actually define, say, the virtual machines to be created. So in the KVM provider, you can say, create me a controller VM via this KVM socket. So yeah, ansible-deployer does a lot more than what I'm showing you today. In BMS mode, it's just going to try and SSH into the IP addresses of the instances that you provided. Again, that's specified by provider via BMS. If you wanted to mix and match, for example, creating your controllers as VMs via a KVM provider, you can totally do that. I mean, if you do something that complicated, please make a talk about it. Come to the next DTNF and like have a part 2 of this session, because I try to run this session every DTNF. But yeah, have a part 2 where you talk through like the super complicated ways to use ansible-deployer. That'd be cool. I would attend that. Roles are where we pick what the individual nodes should do. And this is where we can take our functional blocks and spread our containers across the infrastructure. So for example, in this case, I've got an all-in-one controller. So this one controller node is going to be my OpenStack controller, my web UI, all of my analytics stuff, my control plane, and my config plane. If you were deploying a super high scale Tungsten Fabric cluster, you would start breaking this stuff up. So you would put config, control, analytics all on different nodes in order to scale them independently. It's the beauty and joy of microservices, right? We should be able to benefit from all this complexity somehow. I will also point out that analytics of Tungsten Fabric, I want to say 5.1, analytics is optional. So you don't need to install, I think, the analytics database and the analytics container. You can get by with just analytics alarm and analytics SMP, which are incredibly lightweight containers. I will say that without analytics, a bunch of stuff in the TF UI just doesn't work well, or it doesn't work at all. You are kind of flying blind. I see the little chat bubble incrementing like crazy. So I'm just going to pull up the chat for a second and check out SK's question. Is it possible to deploy one TF controller with multiple instances of OpenStack? No, we don't have, via at least ansible-deployer, the ability to plug multiple OpenStack instances into a single TF controller. So at least through ansible-deployer, whenever you're deploying orchestrators to SDN controllers, it's a one-to-one. Matt Vay's asking, yeah, I didn't have any plans to do a video of this. I definitely can. I have a new TF OpenStack environment I need to build, so I wouldn't mind doing like a screen recording. So let's talk about that in the next TSC. And then finally, SK has another question. Current container deployments based on CentOS, is it possible to go with Debian, for example? Largely, yes. So you can definitely deploy on Ubuntu bases. I'm presuming you mean like the actual host OSs themselves. There's a lot of testing that goes into CentOS, I'm not going to lie. So like the Debian install will, or an Ubuntu, I'll say, install will work. You'll just have a lot of stuff to contend with. You need to make sure like the right version of libraries are available. Things are in the right file paths. But yeah, the TF is containerized, so it should be portable. I did an Ubuntu-based install about want to say 7 months ago. And there were a couple onesie twosie manual things I had to change, and then everything went okay. On Ubuntu and Debian-based distros, our kernel modules will be generated dynamically using DKMS, so you do have some degree of portability. But I will, like I kind of led off with, our testing, our automation, and honestly, the maturity of the deployers is really more robust in CentOS, which is a problem because, of course, CentOS is now streamed itself. So if someone's looking to collaborate on cleaning up the Ubuntu install portions of Ansible-deployer, I would love to help. I'm sure a lot of other people would love to see it. And thanks for the great questions in the chat. So we talked about the controller complex. The compute complex is a little bit more simple. In the compute complex, the role is just vrouter, and then nominally OpenStack compute. I've included a couple more parameters just to make things super complicated. I've specified which interfaces I want vrouter to be bound to, or which interface I should say, but I could technically leave this out and have a pretty simple and straightforward config. I always flash this because I think this is some of the most useful config, and we don't show it in too many places. This has been on my to-do list to address in documentation for a while now. But you can also provide SRIOV virtual functions via OpenStack and Tungsten Fabric. You can do all of the host setup for virtual functions via that configure instances step of the installation. So when you run configure instances, it will set up the host name, the domain suffix, the NTP server, and also stuff like pre-configure the SRIOV VF. This is super handy. If you do this manually, it takes tons of time and it's very complicated to automate. So the fact that Ansible-deployer has all the automation done for you, has saved me tons of time. So I hope this saves you all some time as well. That's it, I think. I don't think I have too many other tips or tricks lurking. Oh yeah, maybe just one. Okay, so this right here, config, there is a process, or I should say there's a container that runs in most of the Tungsten Fabric controller containers, or you know what I mean, a process that runs, sorry, in most of the Tungsten Fabric controller containers called the node manager. Node manager is making sure, or is responsible for making sure that the things configured in the node required for Tungsten Fabric to run are there. Trying to think of a good one. NTP is always the one that bite us. Node manager will make sure, for example, that a node has NTP sync because in a distributed system, consistent time is important. Another thing that's important is having enough disk space. And by default, Tungsten Fabric's minimum disk space required for the container to start is like ludicrously high. I think it's 50 gig or 100 gig, or more than I normally put inside of my virtual machines. So these three configurations, config node manager, defaults minimum disk, database, and config database, these are the three node managers that look for disk. You can set this to whatever the heck you want because this is just a check. So I set this to 2 gig to basically disable the check and then proceed with my install. Node manager will still, and all of these analytics DBs will still grow beyond what you specify as the minimum. So this has no functional impact other than to make your stuff work. And ultimately, that's what we all want, is to make our stuff work. I don't know anyone super interested in this encap priority. This specifies the encapsulation order that should be used. So in this case, I've got VXLAN first, then MPLS over UDP, then MPLS over GRE. Set it however your stuff works. If you're using IP fabric forwarding, it's totally irrelevant. So just leave it as default. And then OpenStack release is important as well. I think we've only gone up to Rocky. Yeah, I think we've gone to, we've got Rocky, Stein, and Train support. In Kolla, I think we're missing Train. So, so I think we're missing Stein. Anyway, Rocky is basically the latest release that I've had the best luck with. This is another area that we need to kind of work as a community if there's interest in seeing support for things like Xena, or I think what's the A one? Aardvark? I think we changed it. It's not places anymore. It's whimsical animals. So yeah, whatever OpenStack A is, we've got some work to do to update this. So yeah, Rocky will work fine. If anyone's looking for new versions, we should work as a community to make the new versions work. Once you have your instances.yaml configured the way that you like, you will run configure. Like I mentioned, that configure step sets things like host names, the domain suffix, the NTP server. It will set up virtual functions and just generally prep the nodes for the rest of the install. It's a quick step. Install OpenStack installs just the OpenStack role and the OpenStack compute role, but that's a whole heck of a lot of containers. Kolla OpenStack is like 14 or 20 containers. Not that it matters how many containers you have, but just there's a lot going on there. So it's a longer part of the install. And then install Tungsten Fabric, or sorry, the install contrail step installs the Tungsten Fabric microservices. That's all this stuff. So yeah, that's instances.yaml. Let's look at one more thing in my remaining 10 minutes, and I can probably even give back a tiny bit of time. Not that that was ever the goal. Okay. So you should all be looking at my web browser. Let's talk about the most important parts of the Tungsten Fabric documentation, and I will embiggen it to drive my point home. In the getting started guide, we have put ansible-deployer front and center, so this should all be a lot easier to consume. There'll be a little bit of information about the 3 steps that we require. There's an example instances.yaml. And then, yeah, there are your 3 steps: configure. I almost said make install. That's how early it is. Geez. Configure, install OpenStack, and install Contrail. Again, sorry for the contrailization here, but a command that you should run to check your resulting installation is contrail-status. You can cringe if you want. These should all be active. So this is reporting back the state of all the microservices in the cluster. If you see incomplete state, so if you see any of these lines that are throwing out errors, you can troubleshoot that error. It's normally something to do with that named container. So if you look on, if it's Zookeeper that's giving you grief, you check on the Contrail database node, check the Zookeeper container. It's normally the one giving you problems. All of our containers output logs to standard out and standard error. So if you check the logs of the container, you'll normally see what's causing you problems. The other space that we stash logs is var log contrail. Again, sorry. We should probably do a troubleshooting Tungsten Fabric session. I mean, if anyone's interested in that, ping me on Slack. Casey, you don't count. But yeah, I mean, I don't think it'd be a full hour-long session, but I bet I could save you all some grief on some of the just common errors. One of the questions that is actually in chat right now is one of the common errors is just making sure that we have a kernel module compiled for the version of CentOS that you are running, because CentOS has CentOS does not use DKMS. We have Tungsten Fabric vrouter compiled against modern versions of the Linux kernel. I think 5.0 and 5.4. Gosh, it's current up to Ubuntu, whatever the kernel in Ubuntu 2004 was. But I mean, that's one of your most common errors when you run Contrail status. You'll see this Contrail vrouter section, and it'll say module is not present. That means you don't have a kmod. You need to get yourself a kmod. How to tell where you should have support and kmods and stuff? Well, that's another super useful part of our release documentation. This is in the release notes, and I've tried to make this super consumable. I realize, like, even presenting it now, there's a lot more we can do, but let's take a look at the release notes for a given release. Right up front and center, you should, and I would posit always will, see a table of the supported platforms. So this tells you what Tungsten Fabric has been tested against in our deploy pipeline. Yes, there's rickety, creaky old CentOS, but there is also Ubuntu 20.04 and kernel 5.4 support. So there you go. It is indeed there and will generate a Kmod. There's also some cool stuff in between, like 4.15 support and 18.04 if you still have that rattling around. And there is newer kernel support for the Red Hat ecosystem as well. If you find yourself on a version of CentOS Stream that you can pin the kernel to 4.18.305, then stuff will work, or 4.18.193. This table should be your map, compass, whatever helpful navigative aid to figuring out what will and won't work inside of Tungsten Fabric and what installer you should be using for it. I talked a lot about Ansible-deployer. I really like it. It's really convenient and it ticks all my boxes as a cranky old Unix nerd, or I guess I have to say Linux nerd in this setting. It's just a simple, straightforward tool. That's not to say that any of these other tools are bad. They're just not my favorite. And Juju Charms are really a close second. There's an open source Tungsten Fabric Juju Charm that's also posted to the Charm store. So if you are a charmed or charming individual, you can check out the canonical deploy. We have documentation for it as well. And maybe that'd be a good follow-up session. Yeah, so with 5, maybe 4 minutes to spare, I'll break here and thank you all for your time. I'm gonna flash the links one more time to show you the location of the Ansible-deployer container. Because honestly, folks, this thing is worth its weight in gold. The amount of times it has saved me from having to troubleshoot Python library dependencies or set up a particular Python environment to run the deployer. And that's it. I will end with our glorious logo. I'm actually wearing, I have a face for radio this morning, but I'm actually wearing this t-shirt as well. So I will leave you with a luscious sea of orange and my thanks for your time. If you do have any questions about the Tungsten Fabric deployer or deployment, hit us up on the mailing list or in Slack. I was having all kinds of Slack problems up until recently, but I have fixed all of my Slack woes. So yeah, if you hit me up on Slack, I will actually see the message now and most likely respond.
Nick, there's a couple
Yeah,
of
thank you all.
questions in the chat. Just wanted to make sure that those all got addressed.
Let me take a look. We will audit the questions right now. So I have answered up to the vRouter for kernel series 5. Matt Bay's question regarding the requirements. 2 CPUs is not sufficient for installations with DPDK. DPDK is a poll mode forwarder, so it's going to take, I mean, Matt Vay's answered his own question. You're awesome, Matt Vay. Because yeah, you're totally right. DPDK will steal 2 CPUs just to run itself. And I keep saying poll mode forwarder. Poll mode forwarder means that the CPU is constantly polling the network queues to service traffic. So the CPU is at 100% constantly because it's always going back and checking, do you have a packet? Do you have a packet? Do you have a packet? Poll mode forwarders give better throughput generally because the CPU isn't contended. That CPU is 100% dedicated to forwarding. The other thing that poll mode forwarding is good for is fixed latency. The thing that it's not good for is that CPU is just pinned at 100% all the time. Kernel mode, Tungsten Fabric does not have this behavior, exhibit this characteristic, if you will. So like when we say 2 CPUs, that's really for kernel deployments or for the controller. That is literally the bare minimum. I believe we wrote and tweaked these guidelines to be minimum system requirements because we wanted to make it easy for folks to get started. But if you have resource intensive or performance intense applications running on top of TF, it can get hungry. In particular, the analytics complex likes having CPU cores, the API server as well. If you're doing a lot of API transactions, it likes having CPU cores. And again, we're finding more topics uncovered with every stone we unturn. There is a lot of performance tuning and optimization that you can do with TF. There's stuff that Matt Vay was talking about, allocating CPU cores for forwarding. There's things that we can do about like API worker threads or, you know, vRouter agent threads, which are used to improve connections per second. So yeah, if this sounds like an interesting area of discussion, I'd be happy to bring some other folks and talk through the topic of Tungsten Fabric performance tuning. Yeah, I think that's all the questions. Matt Vay's question at the beginning is the best. How much time is needed to deploy Tungsten Fabric on a standard laptop? I have a Framework Computers laptop with an i7 and 64 gig of memory. It deploys Tungsten Fabric in about, I want to say 12, 14 minutes. There's nothing standard about that laptop. It is an aberration. But yeah, you know, standard laptop, you're probably about like, you know, 15 minutes to deploy because you're just pulling down containers. There isn't like the multi-node SSH thing. And by the way, that was a plug for my favorite open source hardware company, Framework Computers. Go look at their stuff. It's super cool. That's all. I have nothing further to say, endorse, advertise, or advocate. I will hang out for the rest of these sessions. So if there are questions that trickle in, I'm still here.
Thank you so much.
Yeah, we are
always my pleasure.
currently. Yeah, thank you, Nick. You did a great presentation. We're currently on a break. So the next session will be starting in about 30 minutes. We'll be continuing in the Tungsten Fabric track with Matt Vay's presentation about improvements to metadata and other TF modules. So please look forward to that.
I'm going to go freshen my coffee, then I absolutely will. So thank you all again.
I was going to say, yeah, just please feel free to go do coffee, anything like that. And we'll see everyone again soon.
It's the same bridge, right, Casey? If I just want to like lurk like a loser.
Yes, it will be the same bridge.
Awesome. Okay.
So I'm just about to put everybody can see this day 2